Welcome to this episode of H2O in the Know. Once again, we're coming to you from the Berkeley Springs International Water Tasting in West Virginia. I'm Chris Torres, your host, and in this episode, we'll talk all about resource management for bottled water plants from longtime global bottled water consultant Bob Hidell. Bob has decades of experience in the bottled water industry and has been operating his consultancy, Hidell International, since 1968. So let's get started. Bob, it's great to see you. And I guess this kind of thing was meant to be since you're the first person I met once I walked through the door yesterday. So, how are you?
I'm good. I'm good to be here with you, and I'm glad you're here at this water tasting event. It is the longest running water tasting event in the world.
So you do tons of work when it comes to bottled water, and one part of the work you do involves resource management. Can you explain what that is and how it fits into building and operating a bottled water plant?
Sure. Resource management is another name for the stewardship of global resources. And in the case of those facilities that use natural water sources that they own or lease, such as spring waters or artesian water or even well water, you have to, that is the heart of your business. Without that, you don't have a business. And so the stewardship or the resource management is to understand fundamentally how much water you can use out of that source without impacting the water volume in that source. And so you need to understand the recharge area, how much water on an annualized basis is recharged into the aquifer that's supplying you with that water. The other thing you have to keep in mind is that as you draw on that water, if you're pumping it, you don't want to overpump it and increase what we call the cone of influence, where you might draw other waters from a deeper or further aquifer. And so you have to, the resource management aspect is understanding every aspect of why that water's there and how fragile its universe is when it comes to drafting it or using it. And so we often recommend one of the first things you do is look at your water balance in your production facility. How much water do you use? How much water can you return to the environment? And you create this demand model that says we need this much water on a daily basis or annualized basis or a monthly basis, and we can withdraw this much water out of the aquifer without impacting the quality of the water or the availability to other users. So it's a fairly complex situation. We've been asked to do a number of sustainability studies of aquifers. That takes between 1 and 2 years of research because you have to go through a couple of seasonal cycles. So resource management is securing and sustaining the resource that you're using for your water.
What would you say are some of the things that you would need to find out and determine about particular land before a plant goes up?
That scenario is changing a little. The first thing you need to look at is the politics of the land. And you really need to look at the village, the town, the city, the county that you're proposing to locate your facility in. And my advice is to advise them what you want to do. Because if you don't, and if you don't build a rapport with the local officials and the local politics, the chances are, and even if you do that and they are in favor of what you want to do, either for employment reasons or whatever, that doesn't guarantee that you will not get an uproar from the general public on you're taking our water and you're destroying our land. And that has become a greater and greater issue in siting new plants. However, to try to just go in, buy the land and say I own it and I can do what I want, and the zoning's industrial or the zoning's commercial or whatever zoning you need that allows you to do it, today just doesn't work. And even when you do everything right, it just doesn't work sometimes. Nestle is a top quality company. They have some of the best water managers you can find in the industry. And as you know from reading the press, they are constantly attacked by the general public and land use specialists and so forth. So today, when you talk about what are some of the things you need to observe and be aware of as you begin your siting process, I would say that's number one. Number two is easy. You better hope that the land has water on it or access to it. A lot of companies are going, of course, over to public water supplies and using that and processing it. That's a little less troublesome, but you're still going to get some resistance. Even if you have water and you have favorable town council, city council, planning board permissions, you're still going to get some resistance. And water quality, that's all over the plate. There's no guarantees that you'll end up with the perfect water. You may have to treat it to some extent, which you can in the U.S. relatively easily under our regulations. You may end up with we're sitting in Berkeley Springs, as Chris said, and here the water is coming out of the ground under its own pressure of high quality. And even the town supply is based on the natural waters of Berkeley Springs.
What about other things that might be in the surrounding ecosystem, things such as like animals and plant life? How are those taken into consideration?
When you're looking at the land area that constitutes your recharge area, we do a couple of things. One of the first things our company does is rent a helicopter and do an ocular survey. We look at stuff. We want to see what's around. We want to see the land use patterns. The less development around, the better. If it's an artesian aquifer, it's a little more complex because an artesian aquifer is where you can drill a well into the ground. The water comes up the pipe under its own pressure and stands above the surrounding groundwater table. That's called an artesian aquifer. It is a much more complex hydrogeological environment to assess because it may not be local recharge. It may be the recharge may occur many miles from where you are in a ridge of a mountain where the rocks have been exposed to the surface enough that the water can fall onto those rocks, the rainfall, the snow melt, and filter down under a layer of clay or impervious, sometimes semi-impervious earth material which protects the aquifer. So in an artesian condition, it takes a little more understanding, and most areas in the United States in particular have excellent geological mapping, and so you can usually discern the general areas in which the recharge could occur. But if you're using a spring water source, in the case of springs, all water is local, and in that respect, you want to make sure that you're not near the world's largest dairy farm with cows pooping everywhere, because you will have a biological contamination occurring at some point. Aquifers sometimes come in layers, so you may have a surface aquifer that catches all the precipitation, and if you're near, for example, a residential real estate development and they don't have public sewage, you need to be really aware of that because you can expect higher nitrate values, you can expect perhaps higher biological impacts from waste leaching into the ground. That in both cases, neither of those things are acceptable. It won't work. So those are the kinds of things you need to know what's going on around your plant and your water source. If you're using a municipal source, I also recommend that you need to know where the municipal source water comes from. Is it a set of wells like we have here in Berkeley Springs, or is it surface water impoundments, rivers? Rivers are a nightmare because many rivers are used also for waste discharge, and even though you may be discharging your waste to US EPA standards, very often that discharge will include many pharmacological products. We're a heavily drugged nation, and so we have a lot of very small molecular pharmaceuticals going into the water that can't be treated, in some cases even by reverse osmosis. So river waters, in large part, and particularly if you're downstream from a city, are very, very problematic. They're not easy to deal with today, and you need to have, I would do my own testing of the municipal waters coming into the plant.
So once you found your water source, what's kind of built around it to get it into the plant? Does it involve building some sort of like complex structure or system or anything complicated?
That is a very source-specific issue. For example, if you're taking water from, let's say you have a free-flowing spring that flows from the side of a hill into a pool. In the old days, there are many instances where we would cover the pool, protect it for small animals and kids, and take the water right out of the pool. Well, that's not terribly favorably looked upon today, and very often, and the US FDA that oversees bottled water because it's a food, what happens is the FDA and Hidell International would recommend that you put a borehole into that spring up gradient of the spring and determine that you are withdrawing the same water that's emanating from that spring. And at that point, you can extract the water with a higher degree of confidence that it's not going to experience contamination. Contamination, surface water, one of the indicators we use is coliform bacteria, because coliform is an indication of possible surface water infiltration into your spring water source. If you are using municipal water, I would put in a treatment train that mimics whatever we would do with our spring water, except you'll add carbon filtration, granulated carbon, because you want to remove the chlorine. And by law, all public municipal sources in the United States must be chlorinated. That's pretty much it.
And how does climate factor into where a plant will go?
Let me put it to you this way. Climate is everything when it comes to creating precipitation that makes an aquifer exist or gives you a surface impoundment on which you can draw water. It is all about climate. So you don't want to put your bottled water facility in a desert and extract ancient aquifer water. You would like to be in an area that has adequate moisture available, and yet in the desert you absolutely need the product we put out. So it's a kind of conundrum of you put your plant where your market is. That's the economics. A lot of the decisions we make in this business involve the economics of the business. So it's not just the geophysical world in which we work. It is the economics of the world in which we work. So sometimes you are going to either pipe your water many miles, and that can be many miles, or you can tanker it, or you can put the plant where the source is. And it all comes down to an economic model that works for the particular bottler. So it's a combination of the geophysical world, science of climatology, and of the science of economics and financing and a whole bunch of stuff.
All right, and you've worked in several countries around the globe. What would you say was the most interesting experience that you've had in setting up a plant?
I'm going to cheap out on that answer
and
tell you that there hasn't been an uninteresting one. They're all interesting. They're interesting from a cultural point of view. They're interesting from a geophysical point of view. They're interesting from a client point of view. What our company really does is fulfill the entrepreneurial dream of dreamers. And everybody dreams about being successful in the business they start. And how they approach it, and what their philosophy is, and why they happen to think, in this particular instance, bottled water is the way to go. They bring to us a very interesting perspective on what they want to do and how they want to do it. So I would tell you, just from my own amusement of doing this for many over 5 decades, every one of them is interesting, and it is the people that make it just as interesting as the technical challenges.
You've probably seen more things than many of us could imagine. How much are things involved in terms of resource management?
There are 2 levels of resource management that we have to always keep in our minds. The first is the politics of the resource. And if we were mining gold, there would be politics there. If we were mining silver, precious earth materials, there's always a political layer in that, no matter how you look at your resource. No matter the quality of your ownership, there's always a political and social component to that. And then you have the geotechnical component, which is the science of extracting the water, the treatment of that water, the management of the resource to remain sustainable. So you have both of these, and they have to come together. They must be in a cohort relationship. Otherwise, failure is probably what you see on the horizon.
All right, Bob. Thanks again for joining us on the show today. And this wraps up this episode of H2O in the Know. It was great having you on, and perhaps we could do it again sometime on a different topic.
Anytime.
And make sure you check out all of our episodes from Berkeley Springs, as you're bound to learn a lot from this event that you may not have known about water before. We'll catch you next time.
Music by royaltyfreemusiclibrary.com.